first lesson for the day. I thought we would do a second one for today, doing section 3-2. Not much more difficult than the last section, so this video might actually be even a little bit less than the last one. Some definitions that we have to go over to make sure you remember, but otherwise this should be pretty quick today. So we're going to find the slope given 2 points. We're going to find the slope given an equation of a line. We're going to graph a line given its slope and point on a line, determine if the slopes are parallel or perpendicular, and then solve some average rate of change questions within this nice long video number 3 for the day. And it's only 9:12 in the morning, so we're kicking these out pretty quick. Didn't start till like 8:30. You have the bell ring first one you're on. So we're kind of cruising along with these. So let's go on. Let's find the slope of 2 lines, a given point. Finding the slope. Updated application form. Oops, wrong form. Slope. So slope of a line, 2 distinct points, rise over run. You've heard slope before, it's rise over run. It's your change in y over your change in x. Delta y over delta x. x2 minus x1 over x2, try this again. y1 minus y2 over x2 minus x1. It doesn't matter which order you put them in, you put them in any order that you want. If you want to go y1 minus y2 over x1 minus x2, don't care as long as you go the same direction for both of them. If y2 comes first on the top, x2 has to come first on the bottom. If y1 comes first on the top, x1 has to come first on the bottom. The only thing that can't happen is x1 can't equal x2, because if that happened, you'd get 0 in the denominator, and you can't have that. Pitches of roofs, rise over run. Okay? Ramps, those different types of things. Rise over run. Some people use slope a whole lot. So if you're asked to find the slope between 2 lines, you're finding your change in y over your change in x. I generally say this is, and I like the delta y over delta x, because I figure out how far my x is changing, then I look how far my y is changing. Mathematically speaking, I'm looking at my y's. So we've got 9 minus negative 5. That's my difference in y's. I do whatever's first. And then since I use the negative 9, I got to use the negative 6. Minus 3. Negative 9 minus 5 is 14. Negative 6 minus 3 is negative 9. There's my slope, 14 ninths. Negative 14 ninths. Now, understand that 14 over negative 9 is the same thing as negative 14 over 9. Which is the same as if I put the negative there and write it like that. All 3 of these things are the same exact thing. We talked about that earlier in the course, but that's finding slope. They probably did it a little bit differently than me, but I bet they get the same answer. Look at that, they even did the same thing. So the slope for this one is negative 14 ninths. You can interchange them. Like I said, if you want to switch it around, go ahead. I'm not going to show you that because you understand that. Okay, so that's finding slope of a line. Okay. Can you find the slope of a line given an equation of a line? Of course you can find the slope of a line given an equation of a line. So let's say we're asked to find the slope of a line 3x minus 4y equals 12. Now, so we had this standard form that we talked about in the last section, ax plus by is equal to c. The way I teach this is I say, all right, we're going to put this in what we call slope-intercept form of an equation of a line. So slope-intercept form is anything that's in the form y equals mx plus b. The value out in front of your x is your slope. This part right here is your y-intercept. You're going to find it. We're not really going to talk too much about this today. It's generally speaking, we're just trying to find slope today. So essentially what you have to do when you have equations that aren't in this form is you have to put them in this form. It's going to be interesting. I'll show you what they do. They do this a whole lot differently than this. So I'll click through relatively slow when I click through in this one because they do it differently. And maybe that's the method you would prefer to do it. I prefer to put it in slope-intercept form, so solve for y, and then that value that's out in front of the x is going to be our solution. So if we look at this one, we've got 3x minus 4y equals 12. So I'm going to subtract 3x from both sides. Now, when I rewrite this, that's a y. It's a nice y, by the way. Let's make it a y. So we've got negative 4y. I'm always going to put this negative 3x plus 12. I'm going to put the x first because I want it in this form mx. Now we're going to divide by negative 4. When you divide by -4, divide everything by -4. When you do that, you get y equals negative divided by negative is a positive. So another way to write that, I can just write it as 3/4 x minus 4. All it asked us is for the slope of this line. The slope is the value that's out in front of my x value. So the slope of this one is equal to 3/4. And that's your slope of this line. Again, putting it in the form y equals mx plus b, and we worked on solving equations for variables in the last chapter. So here's how they kind of do it. It's interesting how they do it. Okay, they find the intercepts and then they do it, which is a perfect way to do it, I guess. If you want to find the intercepts, set your x value equal to 0, solve for y, and then they find the slope that way, which is a perfect way to do it. It just takes a little bit longer in my mind. Okay. The next one says find the slope of the line y plus 3. So if we think about y plus 3, if we put it in the form y equals mx plus b, we get y equals -3. Well, if you think about what this graph looks like, y equals -3, we talked about in the last lesson, was this line right here. This doesn't have a slope, okay? So the slope of this line, anytime you have a y equals, the slope is 0. Okay, so the slope of this is going to be 0, because you've got 0x minus 3 here. So the slope of this is 0. And that's always going to be, anytime you have just a y equals and no x value in there, your slope is just going to be 0, because you have that horizontal line, and the slope of a horizontal line is just 0. Okay? And they did the intercepts again so you could see kind of what they did. So then if we have x equals -6, this one's a little bit different. And the explanation that they'll give for this is actually why it works like this. Remember, if you have -6 x equals, it's always this type of situation. So anytime you have an x equals, your slope is undefined. Okay, so it's undefined. It's going up and down. You can't define it. Essentially, you're dividing by 0. So up and down is undefined, and they'll show you that. So you divide by 0, so it's undefined when you're talking about the slope of an x equals. So a couple other things then to kind of keep in mind, and I just said this, an equation in the form y equals, the slope is 0, and the x equals is always undefined, as an undefined slope. Okay, so if we want to find the slope of this graph, we're going to solve for y. They find the intercepts, we're going to solve for y. So we're going to subtract 3x. So you get 4y equals -3x plus 9. Divide by 4. You get y equals -3/4 x plus 9/4. So our slope in this is -3/4. That's our slope for this one. Again, solving for y. Get things you've done in the past. So now if we want to graph a line with a given slope and a point on the line. So if we're going to graph, a line given a point and the slope. So the step one is just going to be to graph the point. So we did this last one. So we're going to graph the point, -3, -2, somewhere right there. Now the slope is 1/2, so slope is rise over run. So it's how much you're rising up by how much you're running over. So if you have a positive slope, you're going up 1 over, in this case, up 1/2. It's probably not the best realization of where 2 is, but your graph is going to look something like this. Okay, that's starting at -3, -2, rise over run, up 1/2 is what rise over run is. Okay, so theirs is going to probably be a little bit more graph accurate than ours, but whatever. Okay, but same thing, change in y over change in x. Now, a couple things. If it's positive, your graph should go up from left to right. So if in that last one we had a slope of 1/2, it was positive. It's going to go up from left to right. If it's negative, it's going to fall from left to right. So negative is going to fall from left to right, and so on and so forth. I kind of say this is up and over, this is down and over. Because this is positive and positive, this is negative. Ooh, let's get rid of that. This is negative and positive. So negative over positive makes a negative. You could also do this if I went like, oops, if I went like this, negative and negative, you could go that way with these as well. Or you could go up and like this for these, because that's positive and negative. I always say go to the right. So if it's positive, go up and to the right. If it's negative, go down and to the right. So the last thing we have to do, or one of the last things we have to do, is determine whether the lines are parallel, perpendicular, or neither. Two non-vertical lines have the same slope. If they have the same slope, they're parallel. So same slope means they're parallel. Non-vertical parallel lines have the same slope. Okay? So if we look at these two lines, we got to find the slope of these two lines to determine if they're parallel or not. So my change in y, kind of do it the quick way. 2 minus 5. So that's my top. Change in y. Change in x. Negative 1 minus 3. So negative 3 over negative 4. And I'm just going to leave it there. It doesn't really matter. Well, let's change it. It's 3/4. The second one, 7 minus 10. 4 minus 8. Negative 3 over negative 4, which is 3/4. They have the same slope. That's 3/4. So these two lines are parallel. They have the same slope. They have the same slope. Sun went behind the thing. They have the same slope. They are parallel to each other. Same slope. Slopes of perpendicular lines. Two perpendicular lines, neither of which is parallel to an axis, have a slope that are negative reciprocals. That is, the product is -1. Also, the lines of the slopes are negative reciprocals of the perpendicular. What? Two lines are perpendicular if it's the negative reciprocal. So if you find the slope of one, you find the slope of the other. You can take the second one, turn it upside on its head, and give it the opposite sign. Then they're perpendicular to each other. If you can't do that, they're not perpendicular. Mathematically, you multiply them together and they equal -1. That's what that says. Okay? So let's determine whether these are perpendicular lines. Ooh, so they give us a little bit more to do with this one. So this is 3x plus 5y equals 6. So we're going to find the slope of this. So subtract 3x. So 5y equals -3x plus 6. Divide by 5. So the slope of this one is -3/5. The second one, 5x minus 3y equals 2. I'm solving for y. So -3y equals -5x plus 2. Divide by -3. So my slope of this one is 5/3. Well, if I look at this first one, it's -3/5. If I flip that over on its head, it's 5/3. That's what this is. So these two are perpendicular to each other. Mathematically, if I multiply these two things together, they should equal -1. That's -15 over 15, which is -1. So mathematically, they have to multiply together to be -1. If you look at them, they're opposite reciprocals, or negative reciprocals of each other. So in fact, these are perpendicular to each other. So last thing really is rate of change in solving problems that deal with rate of change, and we'll just kind of let them do this one for us. So if we look at the rate of change really is just slope. That's all it is. So we use the ordered pairs. 2002, there were 818, and 2003, there were 843. To find the average rate of change, how does it compare to the average rate of change found in the graph below? So you just find the average rate of change using kind of those 2 years. change in y's over change in x's. Okay, so there's your x's average rate of change, and then is going to be taking those and subtracting them and finding your average rate of change, which is 25. So you're selling 25 more. So you've got a positive indicator. That means you're increasing. So the average rate of change is 25. Okay. And we won't worry about that again. These average rate of change ones are really kind of always done kind of in that same manner, where you're going to just find the slope. That's what average rate of change is. It's just the slope over a given time period is what average rate of change is. So there are your 2 lessons for today. I think about 27, 28 minutes total in videos. Again, very well may not have had to watch either of them. Don't know. If you knew how to do this stuff, you've been done for quite a long time. So that's 2 for the day, or 3. I think I'm on the 3rd one. So take care, everybody.